Okay, thank you everyone for joining today. I'm glad that you could join me to learn more about data science in the cloud. So before I dive into today's topic, maybe a recap of what we've been doing this past few weeks. The first thing is we've covered something with Python. That's the data science and cover it. On BMI calculation. How you can create different the other thing we did was these are also other libraries that you can use for data science. And those two libraries, we were able to see how we can edit our charts to tell a story. And then the last thing we covered was an assignment yesterday. So we did, and I gave everyone an assignment to go through the email spam data and wrangle it and try playing around with it. There are two individuals who actually did a very good work on the data on the challenge that I gave. So I'll highlight their projects. So the first one is Mike Adewale, and this is his project. You can see it on GitHub. He has uploaded the data set and he's gone through like the different things we talked about. So how do you check whether there's null? How do you know the contents of your data set and so on? And of course, the different charts. And then the second person who was able to walk around this is Ogerison, and he also shared his data on Discord, how he was able to, of course, go through the data, find like the different meanings of what each column, each row is all about, finding the mean, the median, and of course, doing things such as checking if there's any null objects, and then finally creating charts. Okay. So that was the two people whose data sets I saw, whose notebooks I saw very impressive. So if you did the assignment, you can also drop your data set on the chat and we can be able to, give you a thumbs up and see what's the work you're doing. Also, you can post on Discord as well as social media using the hashtag 30 days of learning. Okay, that's it about a recap of what we've covered so far. So today we're covering mostly data science on the cloud. And the main question you might have is like, what exactly is data science in the cloud? And then a disclaimer, my screen is on my right. So that's why you can see me looking at the right. So we covered a bit on like what exactly is data science in the cloud. No, we're covering about what is data science in the cloud. And you might be asking, okay, what exactly is the cloud? So the cloud is basically someone else's computer whereby you're renting resources such as things like storage, compute, and so on over the internet. So you're renting resources from companies like Microsoft, AWS, Google, and all these companies give you the resources. You can also have your own private data center at home to like give you all these resources that you might need. But then the problem is it will be very, very costly to set up and you might require a lot of capital. So that's definitely a short description of what the cloud is. The next thing you might be wondering is why exactly do us as data scientists need the cloud? So there are a lot of reasons why you might need the cloud, but I just summarize the three main ones. Number one is the scalability. So as data scientists, we need a lot of resources such as GPUs and CPUs and so on as you train your models and as you even go through your data sets and everything. So it might cost you a lot of money to like have all of them in one place, like have multiple cores of GPUs and CPUs in one place. But then with the cloud, you can be able to say, okay, this time we have a lot of data we want to edit, and so we want to predict and everything. So it might necessitate for you to like use a very large amount of GPUs and CPUs, but then after a while you realize, no, you just need a small amount. So with the cloud, you can be able to scale, whether you need a lot or you need a little, you can be able to scale. And then the other thing is reliability. So for example, number one, you can be able to back up your data. And number two, the data is always highly available. No, the service is always highly available. This means that the number of downtimes you may have will be very low. So that's it about reliability. And the last one is security. Most of these cloud services are offered by big companies, which value security a lot. So of course, there's several policies put in place to like say, okay, this is how to secure a site and so on. So that's it about the different benefits of why you should use cloud for data science. So let's get into now the next, which is, 1 second. Okay. So the next thing is now, what are the different ways like you can use data science in the cloud? So there are various applications of data science in the cloud, but I just mentioned two. So for the first one is doing sentiment analysis. Sentiment analysis is when you're trying to figure out how someone feels about something. So you might probably need to extract data from Twitter and probably have it streaming. That's the first question is, okay, when you're getting the data from Twitter, where are you going to store the data? There's storage in the cloud. And then from there now, how are you able to do the cleaning of the data? Then the last thing is now, how are you able to do like predictions? This data might be a lot because you stream it in real time. So maybe you have an event and you want to know how people are feeling, or like the national elections at a specific place. And you want to know how people's feelings are changing over time. So you decide like from a week to the elections, up to like 2 weeks after the elections, we're going to just do sentiment analysis to see how the people are feeling about elections. So there's a lot of data, and probably your computer may not be able to handle it. So that's something you might use the cloud for. And then lastly, predictive analysis. This is whereby you're trying to see, okay, so how many people will buy ABCD when you sell them, or like how are your sales going to look in the near future? So that's another thing. And then after that, the other thing I want to talk about is now Azure Machine Learning. Azure Machine Learning is a cloud-based platform whereby you can do all your different machine learning operations on the cloud. So it has different components that I'll talk about in the next slide. And these components help you now to prepare your data, train the different models, and publish them. And of course, after you've published your models, you might want to look at them and wonder how they're performing. So that's also something Azure Machine Learning will help you with. There are 4 main components that I'll want to talk about, but of course, the components are just a fraction of what else you can do with Azure Machine Learning. But the first one is the Machine Learning Studio. We'll do a step-by-step demo creating everything. So the Machine Learning Studio is now where all the machine learning practices and everything you want to do is. And then the other one is the Jupyter Notebooks. We've been working with Jupyter Notebooks locally on our machines. You can also use the same in the cloud. So you provision your own compute and start working on Jupyter Notebooks in the cloud. And then we have Azure ML Designer. This is a drag and drop interface whereby you just drag different activities and processes that you want to perform, and once you run it, it gets done. And you don't have to write a single line of data when you're doing the Azure ML, when you're using the Azure ML designer. And then the last one that we'll be covering today, and we'll do a demo of, is the Azure AutoML. So the AutoML automates different machine learning algorithms and models that you want to do. So with just a few clicks here and there, once you provision your resource, you can be able to use the Azure AutoML. So we'll explore and we'll do a data set predicting how like the heart failure of a patient will be depending on different components. So I'll now go into the Azure portal. So give me a second. And of course, if you have any question, just type them on the chat. And if you have any question, just type them on the chat and I'll be there to answer. So give me a second while I open up my browser. And then you're going to portal.azure.com. So as I said, we're looking into now like predicting whether someone has heart failure or not. And this data set is publicly available. As you've noticed, most of the data sets we're getting, we're using the data sets publicly available at Kaggle. So we'll use this Kaggle data set. And this data set will has like different columns. For example, things like, okay, what is the age of this individual? This is, of course, a numerical variable, which is an integer. And then things like, okay, how does the decrease of, how is the anemia? Do they have anemia or not? So anemia is like the decrease of red blood cells or hemoglobin in a person's human body. And then, of course, if the person has diabetes or not, if the person has high blood pressure or not, and so on. And there are also some values such as like platelets in the blood. So all of this, if you are good in biology, you may be able to have an idea of what they are, but all of these are used in determining now how is the heart level of a person, are they at risk or are they okay? So yeah, and then the last thing is, at the end of the day, these are the columns that we're using, but we want to determine the death event. So the death event is predicting whether the patient dies during the follow-up period or the patient will still be okay. And then now, if like there's a high risk of the patient dying, you can now start figuring out, okay, how can we prevent the death? How can we ensure this patient is well taken care of, and so on. So we'll go back to Microsoft Azure. And the first thing we'll do is we'll create a resource, machine learning resource. So we'll go to AI and machine learning and create the Azure machine learning. Let me move my screen a bit. I'm missing the last part. Okay. So we'll create the Azure machine learning resource. And while you're creating the resource, of course, you'll choose your subscription. For you, this will be the Azure for Students. And then we can create a new resource group. So we can call the resource group 30 days of learning. And then DSML, oh, we already have that, to science machine learning. That will be 30 days of learning. And then data science, day, and machine learning. That will be on your resource groups. Resource groups are now like the packets where all the resources that you will use for this experiment will be. So one thing you must know about Azure and the cloud is, if you're using a resource, you have to provision it when you're beginning, but at the end of the day, you have to delete them if you're not using them anymore, because if or have them hold for a while, because if you do not pause them or you do not delete them, they'll continue eating up your credits. And you only have like $100 worth of credits, which are very, very easy to deplete. So ensure you always either delete your resources or have them paused. So the next thing is now creating our workspace. So you can call our workspace something like 30 days of learning, and then DS, then machine learning. And you can see it automatically creates our storage account, key vault, and application insights. From there, you also choose like the region that you want. So this is a region that's closest to you. For me, it's South Africa North, but there's also like something like West Europe, which is also close. And then the last thing is now, do you need a compute cluster? In our case, we do not. So we'll do none and then go ahead and create a resource. It takes a while to have the resource created. So it will run past the validation, checking if everything is okay, and then have the resource created. Okay, so as it's creating, does anyone have any question? Anyone with any questions before we continue? Okay. Yes, to me say, I think. Do you have any question? Okay, so silence means everyone understands what's going on and you can be able to follow through. So I'll go ahead and just wait for the deployment to complete. Okay, so once the deployment is complete, you'll go to ml.azure.com. So with ml.azure.com, you'll find all your deployed different machine learning services. So I can take you through a previous, give you a rundown through a previous workspace that I created. We'll wait for what you created to, oh yeah, it's actually done. So this is how the Azure machine learning workspace looks like. So let me go back to here and you can be able to see this is once you've created your workspace, this is what it will look like. Then you'll go ahead and launch the studio at ml.azure.com. And this is the default directory that it will take you through. So as I mentioned, the three main parts of Azure Machine Learning Studio is the designer, automated ML, and the different notebooks. So our focus today is the automated ML, but you can also we'll also look a bit into the designer and the notebooks. Before we go into now, like the different parts, the first thing I want us to cover is the compute. So we have 4 different types of compute that you might need. So the first one is compute instances. These are like resources or workstations that you can use when you're working with data on models. So it might involve creating like a new VM and launching a new notebook instance. And then using that, you can train your model. And then we have compute clusters. Then we have compute classes. So compute clusters are scalable clusters of virtual machines. So if you want to do on-demand processing of experimented code, this is what you'll use. And then we have inference clusters are now like the targets for once you predict something or you deploy a model. These are now the inference clusters. And lastly, we have the attached compute. Attached computes are now like help you to link to existing Azure services. So if you had like a virtual machine or an Azure Databricks cluster, you'll create this. So maybe you're asking yourself, what is the difference between like a CPU and a GPU, and how do you know which one you might need? So CPU, of course, is the central processing unit, and you might have it in you may have a physical one next to you if you have like a desktop or something, and just executes instructions for a computer program. And then the GPU is now something more specialized, and it executes graphics related code at a very high rate. So if you're a gamer, you may need a lot of GPU to like speed up your gaming and so on. So the reason why you might choose something like a CPU and not a GPU is because a CPU is very, very cheap compared to a GPU. Also, and I think that's like the only advantage, like it's just less expensive. But then for GPUs, of course, they're more expensive. That means they are very optimal for things like deep learning, and they have like a higher level of concurrency. So if you want something expensive but perfect, probably you can choose a GPU. Okay, so for our case, we'll go ahead and create a compute cluster. So we'll go to compute clusters and create a new compute cluster. So I hope you are also following along. If you've created your own, if you already have your Azure for Students credit loaded, you can follow along. So the first thing we're doing is creating our compute cluster. We'll leave everything default and we'll go with it. So of course, the main thing you should be looking at is your location, and of course, something like whether you're using GPU or CPU, and then things like now the size of and like the workloads type that you're doing. So for us today, we're just doing classical ML. So we're just doing a training on a small data set. So we just need something small. Also remember like the cost. So this cost is per hour. It's just cents, but as you can see, once I point to them, it tells me the costs per month. So it's just 0.25 cents per hour, but per month it can cost you up to $186 per hour per month. So that means if you're not using it, ensure it's paused. And then of course, we've already created the first part of we've already like specified the virtual machine. So the next part is now configuring the settings. So the first thing is the name. So we'll call it strategies of learning, DSML. And then the minimum number of nodes, we leave it at 0. So if you're not using it, have it at 0. And then maximum, since this is our limit, we can leave it at that. And then the rest, we can just leave it as they are. Must start with the letter. So the DL, and then from there, just create you. And that's it. We've created our own compute cluster. So we'll go back home as it's creating. And probably I'll take you through all the 3 different parts of Machine Learning Studio. The first one is the notebooks. This is similar to like what you already have in your local machines, but available on the cloud. So you can just create a new file here, continue, and then start creating like code and everything. But the only thing you'll have to do is now also provision compute. Once the file is created, you'll also have to provision compute for this. And then, so we'll have to wait until it creates. And then you see no kernel connected, no computes found. So you'll have to like provision compute first before you continue with everything. But it's just the same thing that you see offline on your VS Code. And then the other one is the designer. So the designer is a drag and drop interface. So you don't want to write any line of code. You can experiment with this. And so let me give you an example. Let's look at one of the examples here. Let's look something like this. The regression model of an automobile. It's loading. Let's also give it a few seconds. I'm so sorry, my internet today is a bit slow. But then you'll see like this interface is purely drag and drop. So like the first thing is once you get your data, you can add your data here and then select the different columns in a data set. So for example, which columns do you want to focus on? And then from there, clean your missing data. So you can clean your missing data. We already wrote the code for that. So checking if you have any null and then removing the missing data. So it's the same thing. It will do the same thing. So you have to like specify now the different parameters. And then as your data is, so one of the things when you're doing machine learning is your data must be clean. You can't train a data set which has like missing values or something of that sort. So ensure your data is clean. And then you might be wondering, okay, where is the split data? So once you're done with your cleaning your data set, analyzing, you'll have to split it into two different parts. The first one is the training and then the testing. So you use like a part of your data to train your model and then something that your data has not yet read to be able to test it. It's something similar to like what happens in school. So for example, in school, you might be taught a bit of maths and algebra. And then in the exam, it's not what you learned in class that will come, but you applying what your knowledge to to the test. So that's why we split our data. And then you can see the split data goes to the train model. So you're training using an algorithm called linear regression. And then once the model is trained, you're scoring. So when you're scoring with the trained data and of course the data that you used to test. And then once the score is given, you can go ahead and evaluate the model. So all these commands are found here. So something like clean missing data. So you can search something here, clean, and you can see clean missing data and so on. So, oh no, that's the data. And then the components, so clean missing data, preprocess text, so on. So you can find all the commands here. And of course, once you submit, you can be able to like publish it and share with your friends to see what you've been able to accomplish. Okay, that's about the designer. The last one that we'll be doing today and what our focus will be on is the automated ML. So we'll create an experiment, a new automated ML job experiment to run to evaluate the data set that we just picked from Kaggle and test it and see how like the different evaluation models and so on. So before we start the new ML job, we first have to get our data. So we'll go to Kaggle, and since this is the data that we've already identified, it just has like 266 rows and about 9 columns, if I'm not, 13 columns. So it's a very small data set. So you can go ahead and download. It will come in as an archive zip. So once you've downloaded it, we'll come back to the Azure Machine Learning Studio, go to data and upload our data. So let's give it a minute and we'll create. So we'll upload from a local file. And then the dataset name will be heart failure dataset. Of the data is tabular, as you've seen. The data is in a tabular format. And then the description, probably you can look at what the description Kaggle has just given it. So cardiovascular diseases are like the #1 cause of death globally. It takes about 17 million lives each year and accounts of like 13% of the deaths worldwide. So you can copy paste this here. You can just copy the description here and paste it to your dataset description, because it's exactly what your dataset is. And then go next. So from there, load your dataset. So browse through the files, and once you go to your downloads, this is the file that you load. Then next. So you won't have to do any major changes on anything apart from, so this is like giving you an idea of what the dataset is all about. You won't have to change anything other than the schema. So from our dataset, when we were first evaluating the contents of the dataset, there are some things that we said are Boolean values. So something like sex, you're either male or female, or any other gender that we identify with. So it's a categorical value. Something like diabetes, you either have diabetes or not. So there are these values that have been tagged as integers, but they're not. They are Booleans. So it's either true or false. So we'll go ahead and now change the schema to reflect what exactly we want it to reflect. So the first thing we'll change is something like anemia. So for anemia, it's a categorical value, so it's a Boolean. The next thing we're changing is the diabetes. It's a Boolean. High blood pressure, it's also a Boolean. And then sex and smoking, they're also Boolean values. And lastly, the death event. So it's also a Boolean function, a Boolean data type. And then once you confirm all the details, we go ahead and create. So I'm just going through like the lesson you're supposed to be doing today. So I hope you're also going through with me. And in case you have a question, you can ask as we continue. So after we've now figured out what our dataset contains, we'll go ahead and create a new automated ML job. So the first thing is select our dataset. That's the dataset we want. And then configure the job. So what are we doing? We're doing a new experiment. So the experiment name, 30 days of learning, science machine learning. But target column is now what you're predicting. For our case, it will be the death event. And then compute cluster, we have already created a compute cluster just now. So we'll go ahead and select it. And then what are we trying to do? We're doing classification. We're trying to predict whether one is likely to die because of heart disease or not, depending on the different factors such as diabetes, anemia, and so on. So as you can see, there are also things like deep learning, such as natural language processing, computer vision, there's also time series and regression. So if you want to do drag and drop without writing any line of code, this is the best for you. But of course, since you're going to machine learning this week, that means you'll have to learn a bit of how machine learning works, the different theories and so on. And then, of course, the last thing is selecting now the validation and testing. So how do you want it to test and so on. And then after that, you just finish. So you created your first AutoML job, and it will take a long while to finish. So it doesn't like complete automatically. It takes about 30 minutes to 1 hour or more to train. So we can just leave it to train for a bit. I go to one of the AutoML models that I had created earlier on the same. So this is where it will land you. So you can wait for it to finish. You don't have to do anything. So you can just wait for it to finish. And then this is interesting. So I'm not sure why it's telling me I don't have any. So let me go back to my workspaces. So I did one today on testing the same. So let's see, the experiment I did earlier is completed. So we'll now go to selecting our model. So this AutoML is telling us the algorithm, the model that was the best is the voting ensemble. So we'll probably want to use that as our model. After that, this is what we're now going to do. We're going to deploy the model and see how it will function. So go ahead and deploy. You can either deploy to a web service or a real-time endpoint. We'll just go ahead and deploy to a real-time endpoint. And then we're creating a new endpoint. So we'll just call it 30 days, days of learning, days of learning, days of learning. And machine learning, data science and machine learning. And then compute type managed, and we want to have a key to authenticate it. So hyphen. Then next, we'll now select a model, deploy, scoring timeout 60 seconds, that's 1 minute. Environment, don't have to do anything here. So we'll also have to choose now a new deployment compute. So configure properties for this deployment. I'm not sure why it's giving an error. So let me do true. And then, okay. Traffic, that's okay. So you can leave most of the things as default. Then go ahead and create your model. So once the model is created, you might want to now run this. It's an API, so you might want to run it now in Python or any other language that you might want to now consume your model at. So I think this is now the end of it. So once it concludes, I'll show you the API and how you can be able to consume it to your different applications and so on. So yeah, that's it from my end today. So we're just covering data science in the cloud. That is the lesson that we're doing today. It's the last lesson in the second last lessons on the data science for curriculum. So that's the end of now the curriculum that we'll be doing. From there, we'll start a new curriculum tomorrow, the machine learning curriculum, whereby we'll now be going through, okay, I may have mentioned a lot of buzzwords today, things like training, things like models and so on. So you might want to understand how all this works and of course, how you can be able to implement all this in Python. So yeah, that's it for today. Lukman, you can ask your question. Lukman, you can go ahead and ask your question.
Okay, good evening.
Good evening, Michael.
Thanks for the insightful session. We are very grateful for the insightful session. My question goes thus. My question is that using AutoML or Azure machine learning, can we do all our project? Can we do all the projects in data science and in machine learning using Azure Machine Learning from start to finish? Can we clean our data, prepare our data, and do everything to visualization and creating and deploying our models? Or is there any part left out that we can do with Azure Machine Learning? That's my question.
No, there's nothing that you can do with Azure Machine Learning, but we are in this 30 days of learning, we are guiding you to become like um, an all-rounded data scientist. So yes, you can use AutoML to do all the work that you want. But then for you to now understand the nitty-gritties about now data science, we'll have to go back to Python and learn how to do machine learning in Python, the different machine learning algorithms that you'll need, and so on. So yes, you can do all that you think you can do with AutoML, with the Azure Machine Learning Designer, as well as, of course, you can see there's also the notebooks. So that's also something that you might also need to check out. Yeah. Is that does that answer your question?
Yes, very much. Thanks very much.
Okay, sure. Lukman, maybe you can go ahead. Lukman, can you hear me? Oh yeah, go ahead.
Yes. No, I've already asked my question and you already answered.
Oh, okay, no problem. Anyone else with any question? No, there's no one with any other question. Okay, Ola, do you have anything you might need to add?
Hi everyone. Thanks for the opportunity and well done, Bethany, for the demonstration, despite the little delay that we have before we start this session. From my hand, one question that maybe not a question or a thought that I would like to share is for some people that are here right now, you might not have Azure for Student credit activated. And when you want to practice, that would be a challenge. So we've posted something on the Discord channel, a question that I've pinned from Bethany. If you have not activated your account, use that reply with an emoji, just react to that X emoji. We will know, then we'll just engage you privately and confirm that you're a student. And after that, we can share the process to activate yours so that you can practice along. I mean, from today going forward, you have a lot of use cases that send you back or get you back to Azure to consume those services. And without having that account activated for you as a student, you're going to incur costs. I mean, you're going to incur a lot of costs there. And also, while Bethany is done with that demonstration, if you are done with yours, you need to also learn how to delete and clear your resources, because if you leave it there, as you know, it charges per hour and goes on and on like that for months. And if you forget it, or even if you leave it when you don't necessarily use it, you can leave it for 2 days, 3 days if you want to show people. But when you are done, you should try to close it so that you try to delete the resources so that can save your credit for other things to try. I mean, that's experience. You shouldn't make that kind of mistake. Many of us, we've gotten our hands burnt, not even with the student credit, but our own credit card, learning and practicing Azure, and over, you're forgetting to close those resources or delete them, and we then incur cost at the end of the month. Okay, that's one thing I want to add, and I think that is all for me. Thanks.
Okay, thank you so much, Ola, for that. So we won't be having any other live session for the rest of the week, but we'll be having pre-recorded sessions shared with you throughout the week on machine learning, how you can get started with machine learning, the different machine learning algorithms, and so on. So be sure to check out on Discord. We always share everything on Discord. So if you're not there, please ensure you join and you can be able to check that out. Also, if you're lagging behind and you're not sure where the rest of the students are, let me just drop down a link here. So this link you can use to access the entire curriculum. And in case you have any questions, you can be able to review them and see whether you've been able to reach up to par where everyone else is at. So thank you so much for joining. This was Data Science in the Cloud. Tomorrow we'll be tackling the techniques of machine learning and a basic introduction to machine learning. And then we'll do regression for the rest of the week. Those are very simple topics in machine learning. So don't fear them. Don't fear the word algorithms and models and so on. Just have an open mind and you'll be able to get a gist of what it's all about. And then once you're done with understanding machine learning, that is specific to regression, we'll go ahead and see how we can deploy the models we built using like a web application that will use the Python Flask framework. So you'll be learning a new framework next week, as well as now going into the other different machine learning models. After that, we'll now cover something very interesting, which is you working on your own project, and then you can give us results afterwards. You can tell us, okay, this is my findings and so on. So thank you so much for joining in. If you have any question, don't fear, you can just raise it with either myself or Olan. But from there, I think it's goodbye from all of us here. And thank you so much for joining in. Okay, bye everyone.
Thank you.